Hello and welcome everybody to today's lesson on surface area of prisms. We're going to be looking at rectangular prisms, cylinders, and triangular prisms today. Before we get going on our first prism, there is the link here. I've posted the link in our Microsoft Teams classroom, so you can go there and check out the link. It'll bring you to this website where it'll allow you to just have a little bit more hands-on and exploring and playing around with the different surface area. So you can look at the rectangles, cylinders, and then we won't be getting into volume yet. So you're just looking at this rectangular and cylinder if you'd like a little bit more hands-on with this. But with that, we can get going on the first one, which is going to be our rectangular prism. Now, when we're looking at a rectangular prism, I like to break it down into its individual parts. So you're going to have a top and a bottom, a front and a back, and a left and a right. So we're going to group these together. So the top and the bottom go together, the front and the back go together, and the left and the right go together because they're each going to be the same dimensions for each other. So that's why you just group them together. Now, because I'm grouping it together, what I'm going to do is at the beginning of my formula, I'm going to have a 2. Actually, let's change that color. I'm going to have a 2 so that I don't have to do the work twice. Now what I need is my width and my length plus my height and my length plus my height and my width. And then we'll close that bracket. So looking back to this, I want to first find my width and my length. Now my width is going to be from here to here, which is going to be 5, and my length is going to be from the front here to the back, which is going to be 3, plus my height, which is going to be from here to here, which is 4 multiplied by my length, which is 3, plus my height again, which was 4. Get rid of this bracket here. 4 and multiplied by my width, which is 5. Now that we have it set up this way, we can calculate each individual part inside. So the 2 comes down again, and we have 5 times 3, which is 15, plus 4 times 3, which is 12, plus 4 times 5, which is 20. Close that bracket. Now we have to add all this together before we do our multiplication. So 15 plus 12 plus 20 gives me 47. And the last thing I'm doing is 2 times 47, which gives me 94. And we want to look back. What's our unit of measurement? So we have meters. So meters squared because we calculated the surface area. Now, something that you could have done at the beginning to help you with the setup and so you don't mix your numbers around is label these. So you could have labeled this width, labeled this height, and labeled this length so that when you're putting in the information into the formula, you know that you're staying consistent. Now we're going to take a look at cylinders. So for cylinders, we're going to have to remember to use pi, which is 3.14, but when we're putting that into our calculators, I always want you to use the pi button because it is more accurate. Then we also have to remember the difference between radius and diameter. Now radius is from the center to the outside, where diameter would be all the way across. So in this question here, we're given the radius to use for our formula. Then from the top to the bottom is going to be our height. So we have our radius and we have our height. before we jump into calculating the surface area using a formula, I first want to break this shape down to make it visual on what we're actually solving. So if you think about a cylinder, you have a circle at the top and a circle at the bottom. Now these aren't the best circles I've made, but they'll do the job to get the point. So we have a circle at the top, circle at the bottom. To calculate the area for a circle, you use pi r squared. So we're going to have pi r squared. And then all the way around the outside here, it's going to unfold to make a rectangle. So we would have a rectangle as well, which would be then 2 pi r to find the bottom and our height to find the height. So our 2 pi r really is acting as our width for this rectangle. Now, if we put all this together, the formula for a surface area of a cylinder equals 2 pi r squared, coming from this one and this one, plus our 2 pi r h, because we have our width multiplied by our height. So that's coming from here and here. And that's joining together. And once we add the top, the bottom, and the length and width around the outside, we get our surface area for a cylinder. So let's put all this information in and solve for the surface area of a cylinder. 2 will come down, pi will stay the same. Now we want to use our radius. In this situation here, our radius is 20, so we're going to have 20 squared plus 2 pi. Radius is going to be 20 still, and our height. So our height is 60 multiplied by 60. So we can solve the first part here first, where we would have 20 squared multiplied by pi multiplied by 2. So you would be able to do this all in one go in the calculator. If you want to break it down, what I would do first is square the 20, and then you can do your multiplication. But if we do it all in one go, what you're going to end up with is 2,513.27. When you're not too sure how many decimal places to go to, always go to a minimum of 2. That's going to be the safest bet. The next part, we'd have 2 times pi times 20 times 60, and this will get us 7,539.82. The last part we need to do for calculating our surface area is add these together. So we get 10,053 and 0.9. Last thing you want to check is what is our unit? Well, we have centimeters, and this shouldn't be a meter, this should be a centimeter. So we have centimeters, meaning we're going to have centimeters squared as our unit. So one thing to make sure you do is change that 60 meters to 60 centimeters, because 60 meters would be a lot different than what 60 centimeters would be. Now that's how you would calculate for a cylinder. On the next page here, we're going to look at a triangular prism. When solving for a triangular prism, I always break down my shape into each individual side. So we have a triangle in the front. That's an ugly triangle. Let's do that again. And a triangle in the back. Then we have a rectangle, and a rectangle. So you have 3 different sides. Now these aren't the prettiest looking shapes, but they're going to do exactly what we need. In order to calculate all the surface area, the first thing that we need to do for this is calculate our hypotenuse, because right now we're missing a length that we need to calculate. So in order to calculate this, we need to do a squared plus b squared equals c squared. So we're using Pythagorean's theorem to solve for our hypotenuse. Now we have 12 squared plus 6 squared equals c squared. So 144 plus 36 equals c squared. 180 equals c squared. Find the root of 180, which gives us 13.42 for C. So our unknown is now 13.42. All of our measurements, we can start filling in the diagrams that we drew. So for the triangle, we want to look back and we have a height of 12 and a base of 6. So a height of 12 and a base of 6. Height of 12 and a base of 6. Then we want to calculate for one of our 3 rectangles here. So if we say we're doing this top here, we're going to have a width of 13.42 and a length of 15. Now if we switch, this is 13.42, put that back. If we were to do this back side here, we would have still a length of 15 and a height of 12. Get rid of our lines that we've made here just to see it again. Then we want to do our bottom, which is still a width of 15, and then we have the length of 6. So notice how the 15 was consistent all the way through, and then your width was based off of which side you're measuring. So now we have all of our diagrams set up. We just have to calculate for them and add it all together. When you're usually calculating for one triangle, it would be base times height divided by 2. But in this situation here, because we have 2 triangles, we're not going to be dividing by 2 because this would fill in this spot perfectly. So if you took this, flipped it over, it would fill that in perfectly, meaning we don't have to divide by 2 here. So the first thing we need to do for this one is the surface area for this equals 6 times 12. 6 times 12 gets us 72. For the rectangle here, we do length times width. So length times width is 6 times, or sorry, not 6, 13.42 times 15, which gives me 201.3. For the second rectangle here, we have 15 times 12, so length times width, which is 180. And then for our last one, we have 6 times 15, which is 90. So we've calculated for the 3 rectangles and the 2 triangles. So we have 72, 201.3, 180, and 90. The last thing that we need to do is calculate our surface area by adding these all together. So take our 72 for the triangles, and then we can add our 3 rectangles, which were 90 plus 180 plus 201.3, and our surface area equals 543.3. Looking back up, we have feet, and because it's surface area, it's feet squared. Now we have a different layout of a rectangular prism. So we're going to be first having to look at calculating what the height is for a rectangular prism. If we go straight down from the middle, right here is going to create a right angle, meaning that this side is 5 and this side is 5 because we're splitting it in half. This is going to allow us to calculate our height for our triangular prism, and this will allow us to calculate the surface area of those sides. Meaning, we want to, again, draw out the shapes that we have. So we have a triangle on one side, triangle on the other side, so the front and the back you could call it. And then we have our three sides, which are going to be our rectangles. So we have one rectangle, another rectangle, and our third rectangle. Remember, these don't have to be perfectly to scale, they're just there to assist you. Now, before we can get going, we have to calculate what the height is going to be for this triangle. Previous problem, we used Pythagorean Theorem to calculate for what that hypotenuse was, and we're going to use, no, that should be an equals c squared, and we're going to use the same to calculate for this. In this instant, though, we have 5 as our bottom and we have 8 as our hypotenuse, so we're trying to figure out the height of it. So what we know is a squared is going to be our h squared plus b squared is our 5 squared equals c squared, which is our 8 squared. Now, h squared stays the same, plus 5 squared is 25, equals 8 squared, which is 64. The next thing that we need to do is bring the 25 over, so we're doing the opposite, subtract 25, subtract 25. So we get h squared by itself equals 64 subtract 25 is 39. Then we find the root of 39 to get h, which equals 6.24. So now we can go back up here, and we know that instead of h, we have 6.24. I guess I'll put h equals 6.24 just so we know where that number came from. Once we have this, we can lay out our triangles. So we have our triangle here and here, and we have 10 across the bottom, and we have a hypotenuse of 8 and a height of 6.24. Now I'm just going to write this on the side and then just draw an arrow into there. Again, 10, 8, and 6.24, and then drawing an arrow to show where it goes. Now we can do our three sides. If we use one here, we have 18. So 18 is going to be our consistent part because it's our width for all of them. So 18 again and 18 again. The next thing we need to look for is the length of here to here, which we know is 8. And then the length from here to here, which we know is 8. And then the length across the bottom, which we know is 10. Now, Reminder that these aren't to scale, so they don't look the appropriate sizes, but they're there just to help us calculate. When we're calculating for the two triangles, we're going to use the base and the height. So we're going to have base multiplied by the height. 10 is your base and 6.24 is your height. We could have also used 5 and 6.24 because that would one side would flip over to complete the rectangle, but then we're going to have to times it by 2 in the end. So if we use the 10, which is the whole length across the bottom, and the height of our triangle, we don't have to multiply it by 2 then. So our base is going to be 10 multiplied by our height, which is 6.24, and that'll give us 62.4. Then we have our length times our width, which is 18 times 8. 18 times 8 is 144. We have our length times our width again, which is 18 times 8. 18 times 8 is 144. And then we have our length times our width, which is 18 again, times our width, which is 10, equals 180. We've now calculated the surface for all of our individual pieces, and we can get our total surface area by taking our triangle, which was 62.4, plus, let's see if I can get this out of there, 62.4 plus our 180 plus our 144 plus our 144 again, and we get a total surface area of 530.4, and looking up we have millimeters, and it's going to be millimeters squared. So this is going to be how you calculate for the two different types of triangular prisms. Remember, first break it down into its individual shape. For this type here, we have to calculate the height before we can move forward. And for this type, we had to calculate our hypotenuse before we can move forward. So this will be the end for the lesson today. Make sure you go on to Delta Math after and complete the homework that's assigned.